So we'll talk about what a spontaneous reaction is, the relative reactivity of different elements, and the connection between the periodic table and table 14-1 in Wiley. We'll also discuss identifying oxidizing and reducing agents. So what is a spontaneous reaction? Well, some chemical reactions occur by themselves. If we light a candle, it continues to burn. Some reactions, however, only proceed as long as we put in work. An example of that is chrome plating a car bumper. That takes a lot of electrical energy. Here's a picture of that. The process is long and involved. We know some elements are more reactive than others. Gold reacts with very few other substances. It keeps its shine for thousands of years. Sodium metal, on the other hand, reacts very violently with water. So why is that? We've seen that the goal of chemical bonding is for elements to get full electron shells. They want to be like noble gases. Group 1A elements want to lose electrons. That's the shortest path. Group 7A elements gain electrons. Let's look at a periodic table. A group 1 element like sodium easily gives up its electrons. They're very reactive. A group 7A like fluorine, those elements want electrons badly. They're very reactive as well. Elements in the middle tend not to be very reactive. So Wiley table 14-1 takes a few elements, a few other species, and summarizes this in terms of oxidizing and reducing agents. The elements on top want to gain electrons, fluorine, chlorine. We've seen that from the periodic table. They want to gain electrons badly. Elements on the bottom of this table 14-1 want to lose electrons. They are very reactive. They are very strong reducing agents. Elements in the middle, somewhere in the middle. So we want to work problems using this table. The first thing we're going to have to do is determine which reactants are oxidizing agents, which are reducing agents. It's easy to get turned around with this due to the terminology that they use, also the fact that electrons have negative charges. So whenever I work this problem, type of problem, I start with oil rig. Oxidation is loss of electrons. Reduction is gain. Let's determine oxidizing and reducing agents. A reactant that gains electrons is reduced. A reactant that is reduced is also called the oxidizing agent. A reactant that gains electrons, therefore, is the oxidizing agent. Look for the element that is gaining electrons. That is the oxidizing agent. Fluorine, chlorine, and oxygen, very strong oxidizing agents. That's where the name comes from. Oxygen is a strong oxidizing agent. All of these want electrons badly. On table 14-1, read the oxidizing agents from left to right. Let's take a look. We go from left to right. The weak oxidizing agents, sodium plus, magnesium 2 plus. The strong oxidizing agents, like we said before, fluorine, chlorine, oxygen. The elements in the middle are in the middle of strength of oxidizing agent. Let's look at reducing agents. Reducing agents come from a reactant that loses electrons. A reactant that loses electrons is oxidized. Remember oil rig. A reactant that is oxidized is the reducing agent. A reactant that loses electrons is the reducing agent. Sodium, magnesium, aluminum. We saw they're all located on the left of the periodic table. They want to get rid of electrons. We read reducing agents from right to left on table 14-1. We read the reducing agents going from right to left. The strong reducing agents, sodium, magnesium, aluminum, they want to get rid of electrons. Weak reducing agents like F- and Cl-, they have full outer shells. They do not want to get rid of any electrons. The other elements, somewhere in the middle. A spontaneous reaction occurs when a strong oxidizing agent reacts with a strong reducing agent. Look for the oxidation agent on table 14-1. If you can get to the reducing agent by moving to the right and down in a clockwise direction, then the reaction is spontaneous. Let's look at some pictures. The strong oxidizing agents, if we start with one of those, we move down and to the right, and our other reactant is a strong reducing agent, then that reaction is spontaneous. We're moving clockwise along this table. Conversely, if we start with a weak oxidizing agent and we move in a counterclockwise direction, our other reaction is a weak reducing agent, those reactions are not spontaneous. So we discuss concepts behind what makes for a spontaneous or non-spontaneous redox reaction. We talked about oxidizing agents, reducing agents, and how to apply them to table 14-1. We'll work some examples in the next video. If you have any questions about these concepts, contact Corey or myself. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.